Week 11, 2023. Here's some more EOM questions, answers and solutions and work stuff to questions. I do a few more in a video and then do a few more in another or two instead of doing them all at once. So do another one like the first one I did. The other one had more complexity because you started with something up on a hill, up on a building, and you threw something upwards, then had to go down. So whereas that one, we started on some tall building, and on that one, something was thrown upwards, and then it would fall down from there. This time, it just drops from the building. I need to clean these things. They're getting marker dust on my hands, and it's annoying. So, here, a ball is dropped. Remember, keyword dropped means initial velocity is 0. We need to get the information here, put it in context of what we know about the real world, diagram, equation, solve. Connect to the real world, please. Okay? It's important, like I know I'm doing some calculus, related rates, doing a problem with some dough to make a pretzel. Someone gets some dough and rolls it out. And then there's some information people have, and people are trying to figure out, how do we do the problem? How do we do the problem? Think about the real world, please. It's important. In the real world, you get some dough and you roll it out. What stays the same? What remains constant? The dough that you're using. So the volume is the same no matter what happens to it. It's just when you roll it out, you start with the little thing and you roll it out and the length gets longer and it gets thinner, it becomes a cylinder. You start maybe with a cylinder of a certain length, so this length becomes longer, the height of the cylinder, and the radius of the cylinder decreases. Height is changing, radius is decreasing as you roll something out. But the same stuff is there. So think about, and then once I say that, then people are like, oh, I get it. Then they can start applying their math to the real world situation, as we talked about. Experience. Conceptualize that. And then apply math to your conceptualization. Okay? T-O-K, yo. So think about the world. We get this, we have a building. Something's dropped, as we say. In the real world, that means it starts with 0 velocity. That's why I discuss that stuff, to help you understand the importance of thinking about the real world and not getting lost in words or lost in math or lost in this. Get it and put it in context of the world. So in this one, dropped, initial velocity 0. And I'll put all the stuff in the previous one I did. I just went into it because I had limited time, but I'll write the stuff down this time. The given, so it's dropped, 320 meters tall. What is its speed when it strikes the ground? So we got, this is 320 meters. And initial speed is 0 meters per second. I won't put the meters per second, then there's a bunch of letters and it could get confusing. Acceleration, we know negative 9.8 meters per second squared. And then the building, 320 meters. And we want to find final velocity. So we have the stuff written down. And remember, a good strategy is to get these things, find the equation of motion, the EOM, with these 4 things in it, pick that one, and then you know what to do to solve. So in this one, look at your formula sheet, your data booklet, or those things you have written down. Look at these, look at the ones. You're going to find out that this goes with v squared is u squared plus 2as. try to make some of this as easy as possible. Bring it down sometimes to the elementary school level. Just match up the letters. And so then we plug in v squared is u squared plus 2, 9.8, 320. And I'll leave it positive. It's going to be going down 320, and the 9.8 is negative, and a negative times a negative is a positive. So if we understand that, we can just leave it like this, okay? But if it starts here and the S is at down 320, you need negative 320. But, because you know, when we square root, we're going to square root a positive. So you got that context for it too. So exactly, I could approximate, that's about 10. 2 times 10 is 20. Multiply this by 10, because 20 is 2 times 10. You get 3,200. Double that, 6,400. So something around 6,400. Then we square root at that. And that'd be what, 80? So something around 80 would be our final answer. 2 times, unless I messed up my mental math, times 320, 6272. And square root. $79.2. As I said, it's around 80 meters per second. Okay. That is how you do this one. Look at the given information, draw a diagram, think about what's going on in the real world, so you can get some of the stuff that's not stated explicitly. Pick out your equation and solve. Okay. Then try another 1 or 2 or 3 or something in here. Which other one is I looking at for now without angles in it? This one. So some, a lot of people got right. I won't do those. Only 3 through 9. And I did number 4 already earlier. And I just did number 8 of 9. Forgot to put that up here earlier. And this stuff, this is number 8 of the 9 we did. And got that. Yeah, cover a topic here, remind me, and then I'll do this one. Pretty straightforward. So before I do number 5 of 9, remember units. Distance or displacement is like in meters or kilometers or feet or whatever. I'll just put this and get the idea. Distance in meters or something equivalent. Meters, inches, feet, miles, light years. Speed or velocity. Meters per second. Or kilometers per hour, or miles per hour, or inches per day, or something like that. Okay. Acceleration. Meters per second squared. And this can be like, they'll do it like that on the IB sometimes. Meters second to the negative first. And then make sure you know this means meters per second, because it's a change in velocity per time. So we should know that, I'll fall asleep, computer, that If it's meters, it's distance. If it's distance, it's meters. If it's meters per second, it's velocity. If it's a velocity, it's meters per second. If it's meters per second squared, it's acceleration. If it's acceleration, it's meters per second squared. They go together, okay? This is in this units, and these units are this. That's something we should know. Like, deep down, memorized by habit, by rote, second nature. Okay, now, number 5 of 9. A race car driver traveling at 15 meters per second accelerates at a constant value for 10 seconds. She is now driving at a speed of 35 meters per second. What was her acceleration? So, she was going along, and then she sped up. So she's going slower, and she went faster. Like she's running, and then she's running faster. Okay? So, we know the velocity is changing. A change in velocity means acceleration. It means there was a force on something, a push or pull. So we got one speed and a later speed. Initial speed, final speed. Whoops. I wrote 0 accidentally thinking about the other one. 15, 35. Since we know it's speed, meters per second. Time, 10 seconds. Acceleration is what? So we have 4 letters, U, V, A, T. UVAT. So which equation do we use? Formula sheet, booklet thingy, look for the equation. We see we use because your final velocity is your initial plus how much total it changes. Okay? Know that, like, in terms of words in the real world, and we put math to it. So, 35, 15, plus A times 10, subtract the 15, divide by 10, 2 meters per second squared. That is our answer. Okay. Then small package number 3. So I did 4. I did 5. 7. I'll wait until the next video. I'll do it with the other ones when I'll do it with the other ones with angles in them later. These will be no angle problems. So, which one? Where did it go? 3. Okay, yeah. So, 3 of 9. Notice for this one, we didn't really need to draw a diagram. So, 3 of 9. A small package is dropped from a drone hovering at a height of 30 meters. Hopefully it didn't break. Maybe just like the future of Amazon, you know? A package is dropped. Or maybe it's something to save someone. They're like down somewhere 90 feet. And there's a drone at ground level and it draws something to them or something. How long will it take for the package to reach the ground? So, we have a drone drops a package, and the drone's 30 meters up. Here's my ground. $30 meters off the ground where the package is. And we'll assume the package is 30 meters up. hopefully the package and the drone don't take up too much room, so the package isn't falling from 29 meters or 29.5. But the package is 30 meters up. How long will it take for the package to reach the ground? And again, dropped, bing, bingo. What happens in the real world when we drop something? Initial velocity is 0. So there's information implicit in the problem. We need to know how to get that. U is 0. S is 30. We know we're dealing with free fall, so acceleration due to gravity. And then how long to hit the ground. Okay. Then we look at our equations and see which one could be used. Yeah, like on the other one. No, I won't get into that right now. But the one we could use is S equals UT plus 1/2 AT squared. And notice I modified this in that first video I did to have like an initial thing in it. The other one we could have done in 2 parts, but I did it like this. No, we can. And that's something, you know, you need to know how to do. We need to know how to go beyond what is taught. To get, like, on average, 4, more or less, 3 or 4, 4 or 5. Looks like last year in the new program, not the old program, not the one, the new IB program in physics, but in the other one, the last, in May of this year, I think it was, if I remember right, it was that exam where the SL, most people got like a 3 or 4, 20% something, but on the HL, most got like 4 or 5. That was like the peak of a distribution. So varies a little bit depending on HL or SL, but you know, around 4, but that'd be average. To do better, you need to go beyond what is taught. So there has to be some questions that are discriminating that people have not even had explicitly that you need to be able to work out to get that higher rating. Okay. So it might be like doing something like this as a simple example, but adding the extra thing in there, the S naught, like I did in the other one. But in this one, straightforward. So put your numbers in. As I say, write down the given. Find the thing with the same 4 letters in it, letter matching, then plug and chug. So 30 is 0 times t plus 1/2 9.8 t squared. Now, if you do negative 9.8, then you got to do negative 30 to be able to take the square root, because it dropped 30, it didn't go up 30. Displacement is down 30, not up. But since I know that this and this are in the same direction, I can ignore the sign. They're going in the same place, so they're not opposite. Then 30, 4.9 t squared. So it's going to be around the square root of 6, so like 2.45 or something seconds. But if I use the 4.9, 30 divided by 4.9, 6.12, square root. So 2.47. 2.47 seconds. S for seconds. Okay, that's how you do that one. And then I'll do more later with the angles in them. But there are a few from the quiz we did. More coming later.